Welcome to this explainer. We are going to explore how the web is undergoing this massive yet completely invisible shift right now. For decades, the internet has really only moved in one direction, right? Creating interfaces built exclusively for humans. We have visual layouts, colorful buttons, and interactive forms designed specifically for our eyes and hands. But today, we're moving from an interface built just for us humans to one optimized for AI agents. We are quite literally rewiring the web to give machines a native way to interact with our sites, and it's absolutely going to change how we all use the internet. Okay, let's jump right in with a pretty fascinating question. When you ask an AI assistant to, say, book a flight or buy a shirt, how does it physically execute that click? I mean, if an agent doesn't have eyes to see a screen or hands to move a mouse, how in the world does it navigate a checkout page that was designed entirely for human interaction? To answer that, we really have to look at the contrast between the old way of doing things and the new way. Currently, AI acts a lot like a tourist who has zero clue how to speak the local language. To use a website, modern AI agents literally take a screenshot of the page, send it over to a vision model, and then try to guess where the buttons are based on the pixels. Or they have to read through thousands of lines of raw HTML code to figure it out. It's just highly inefficient. But the new way? It changes the game completely. It gives the AI a direct, native, programmatic map to the website's functions. And for you and me, this ultimately means smoother, faster, and infinitely more reliable AI assistance. So, here is our roadmap for today. First, the agent browsing problem. Second, enter WebMCP. Third, how agents actually connect. Fourth, client-side versus server-side. Fifth, user consent and security. And finally, number 6, the agent-ready web. All right, let's kick things off with Section 1, the agent browsing problem, the cost of guessing. Think about it like this. Asking an AI to reverse engineer a human interface, like parsing CSS, reading screen pixels, or crawling an accessibility tree just to find a checkout button, is exactly like trying to read a menu by looking at a photo of a restaurant's dining room. The information might technically be in there somewhere, but extracting it is painfully slow, super unreliable, and prone to breaking if the layout shifts even slightly. Literally, if a developer moves a button 2 pixels to the left, the agent might completely fail. And simulating human behavior like this, it's just economically unsustainable. When an agent has to take a screenshot, run a vision model, guess the coordinates, click, wait, and then take another screenshot, it eats up massive amounts of compute. We're talking up to 50,000 tokens just for a simple e-commerce workflow. Plus, as we mentioned, it's highly fragile. Something as simple as a delayed pop-up ad or a slightly different mobile layout can completely break the whole automation loop. Which brings us to Section 2. Enter WebMCP, the USB-C of AI agents. So how do we fix this? With WebMCP, it's a proposed web standard being incubated right now by the W3C, and it's co-developed by engineers from Google and Microsoft. By using a new browser API called navigator.modelContext, WebMCP creates this universal connection bridge. Instead of forcing the AI to guess what's on the screen, a web page can explicitly hand the agent a structured menu of tools. It's actually being called the USB-C of AI agent interactions because it aims to be this single, standardized interface that totally replaces the messy tangle of screen scraping hacks we're stuck with right now. And the data here really highlights the staggering impact of having this standardized connection. By bypassing that clunky HTML parsing entirely and just using WebMCP's structured data, developers are seeing token counts drop by an average of 67.6%. That is huge. And at the same time, it massively boosts success rates and decreases latency simply because the agent isn't sitting around waiting for visual rendering of the page to decide what to do next. Okay, moving on to Section 3, how agents actually connect inside the machine layer. To really grasp this connection, you have to realize that WebMCP doesn't change a single thing about how websites look to us. The human layer stays exactly the same. We still get our beautiful visual HTML, the CSS layouts, the nice aesthetic buttons. What WebMCP does is quietly add a parallel machine layer running right underneath it all. This layer is entirely invisible to humans, but it's perfectly optimized for AI logic, relying on JSON schemas, explicit parameters, and programmatic tool definitions. Let's look at how this builds out in real time when an agent visits a site. It's a clean 3-step process. Step 1 is discovery. The agent essentially taps the web page on the shoulder and asks, "Hey, what tools do you support?" Step 2 is capabilities. The site responds with exact JSON schemas, clearly laying out what inputs it expects and what outputs it will return. And step 3 is execution. The agent calls the tool with the precise structured data required.
The whole interaction happens in one single, highly reliable round trip. Let's put this into a concrete example so it's super clear. Instead of an AI agent awkwardly crawling a travel page looking for a visually labeled search flights button, crossing its fingers that it guesses the right text fields, the agent simply calls a programmatic tool. Let's call it Book Flight. It passes precise parameters like origin, destination, outbound date, and passenger count directly to the function. This means a task that used to take multiple screenshots and simulated clicks now happens instantly through a clean, totally predictable function call. Section 4. Client-side versus server-side, where the code runs.
Now, you might have heard of Anthropic's Model Context Protocol, or just MCP. So what's the difference? Well, standard MCP connects AI models to external backend servers using API keys, but WebMCP runs client-side, directly in your web browser. And this distinction is actually massive for everyday users. Because WebMCP lives in the browser right alongside you, it seamlessly leverages your existing logged-in session, your cookies, and your browser authentication. So the AI can act on your behalf to manage your calendar or check out of a shopping cart without you needing to set up complex API keys for every single website you visit. It just works.
Next up, Section 5. User consent and security, human in the loop.
Obviously, with AI acting directly inside our authenticated browser sessions, security is a huge deal. WebMCP is built fundamentally around explicit human-in-the-loop consent. Because it operates on the browser's origin-based security model, an AI agent cannot silently add items to your cart or submit forms in the background. No way. Whenever an agent wants to execute a tool, the browser will pause and prompt you. This prompt shows you exactly what the AI wants to do, the tool name, the description, and the parameters it wants to pass. You have to approve it first, which puts you firmly in control of the interaction every single time.
And finally, Section 6, the Agent-Ready Web, Optimization for AI. I absolutely love this quote because it hits the nail right on the head regarding the magnitude of this shift. Just as websites optimized for search engines in the 2000s, WebMCP represents the next evolution, optimization for AI agents. We are moving from the era of SEO, making sites readable for search engine algorithms so humans could find them, to an entirely new era. Moving forward, making your site usable and highly functional for AI agents is going to be the absolute ultimate competitive advantage for businesses on the web. So, as we wrap up this explainer, I want to leave you with a provocative thought to chew on. How does your website look to an AI today? Is your digital presence forcing AI to act like a lost tourist, fumbling around with screenshots and guesswork? Or are you getting ready to hand it the map? Because the agent-ready web is here, and the way we build for it is changing forever. Thanks for joining me on this deep dive into how WebMCP connects AI agents.